In this question, we are asked to find the equation of the tangent to a curve at the point 9a 9/4a. This is a coordinate of the of a point on the curve, and the equation of the curve is this 1/√x plus 1/√y equals to 1/√a, where the x is greater than 0 and y is greater than 0. Actually, this doesn't matter first. Alright, so then okay, so how do we find the equation of the tangent? You know, tangent, when we say tangent, it means that, let's say if this is the curve and the tangent at any point would be this. Let's say, for example, this point is the point on the curve, x coordinate 9a and y coordinate 9/4a. So the tangent to the curve has the gradient of the tangent to this curve at this point. Okay, so that means a tangent must always be a straight line, right? Tangent is always a straight line touching the curve at one point, right? And parallel to the gradient of the curve at that point. So a straight line always have this type of equation: y equals to mx plus c, where m is the gradient of this straight line tangent. Okay, so and c is the y-intercept of this tangent line. So maybe the c is here. The graph is not drawn accurate. I'm not drawing this graph. I'm just giving you an idea by drawing any curve and showing you what's the concept of a tangent. So in order to find equation of a tangent, first thing we need to find, we will need to find the y-intercept of this line, tangent line. We also need to find the gradient. So how do we find the gradient? Okay, the gradient is simple, because since the gradient of this tangent is the same as the gradient of this curve at that point, so we find the gradient of the curve at that point instead. So gradient of tangent at 9a 9/4a, this coordinate, is equals to gradient of the curve at 9a 9/4a. And how do we find the gradient of the curve? Recall that the dy dx, right? If I find the dy dx of this curve and then substitute 9a into the x, this is the x coordinate, and 9/4a into the y, then I will be able to get the gradient, right? That means dy dx is the gradient of the curve at this point where x equals to 9a, x coordinate, and y coordinate equals to 9/4a. So we need to try to find this. When we find this, we find the gradient of the tangent. Right, so let's try to find this. Okay, so here we will make use of implicit differentiation. That means we implicit term by term with respect to x. So can I change this equation to something that you will be more familiar with? X to the power of minus half, because root x is at the denominator, hence this minus, and root is to the power of half. So y to the power of minus half equals to a to the power of minus half. Okay, so when we differentiate implicitly, it is just minus half x to the power of minus half minus 1. The power will reduce by 1. The minus half bring in front. Alright, differentiate with respect to x. Alright, so if you use chain rule, this is just this, but dx over dx is just 1. This thing is just 1. So usually we ignore this and we don't write. But for y, it's different. When we differentiate y, okay, so we have minus half, we will bring in front. Minus half times 1 is minus half, then y, then the power reduced by 1 again, and then we will differentiate using chain rule, right? We'll have to differentiate dy dx. Okay, so we get our dy dx from here. Then this is since a is just a constant, right? A is a positive constant in this question, so then this, when we differentiate a constant, it will become 0. Okay, so if I move this over to the other side, I have minus half x to the power of minus 1 minus half is just minus 3/2. minus 1 and half is just minus 3 over 2, so equals to half. This bring over to the other side, therefore minus half becomes positive half, y minus 3 over 2 dy dx. Okay, so then if I bring all this over to the other side, then minus half divided by half will be minus 1. Okay, minus 1, then x to the power of minus 3 over 2, then divided by y to the power of minus 3 over 2. Correct? So this is equals to my dy dx. Okay, this is dy dx in general, but we want dy dx when x equals to 9a and y equals to 9 over 4a. So then we'll just substitute 9a inside here. So before that, I want to do some simplification. Since both of these is negative, so negative will go, okay, so x will go to the denominator and y will go to the numerator. But since both of them has the same power, 3 over 2, I can write this way. Why is it not negative? Because I have already switched the position of y and x, y to the numerator and x to the denominator. So when x moves to the denominator, the power becomes 3 over 2, and y move to the numerator, power becomes 3 over 2. So I just put this. Okay, remember, okay, this thing, a over b to the power of m equals to a m b m. That's why I can simplify to this. So that is dy dx. But now if I want dy dx equals to x equals to 9a and 9 over 4a, so I just substitute 9a inside for my x. So this one become minus 9a at the denominator, and the numerator will be y, so 9 over 4a over here. So this has to be longer to indicate that it's actually this thing divided by this thing. Okay, so then divided by then the power of 3 over 2. Okay, so then over 2 means I square root each of this number. Right, so it's equals to, I'll just do it slowly for the sake of like students who are not so good at algebra yet. So like, let's say, okay, square root everything, square root each of this term, because there's a power half here. So this will become okay, firstly a and a will cancel, because a divided by a is just 1. Alright, so these two will cancel, you just have to have 1. Then after that I root each term, so this will be 3, 9. 2 will give you 4, therefore the root of 4 is 2, root of 3 is 9 is 3, root of 9 is 3, then the root of 9 is 3. Okay, so this is the longer, right? Then after that I've taken care of the power half by square root each of these number. Now I want to, okay, before I go to here, I can make a simplification. So 3 divided by 2 divided by 3 is just half. Okay, because it's actually this one, you can rewrite it as 3 over 2 divided by 3 equals to 3 over 2 times 1 over 3 equals to cancel, so we just did half. Alright, so then after that this would give me equals to minus 1 over 2 to 4, 4 to 8. 1 times 1 times 1 is still 1. Then the minus from the outside. Okay, so then what else? Since this is minus 1 over 8, I know that the gradient of the tangent at this point is minus 1 over 8. That means my m, in other words, my m is minus 1 over 8. So y equals to minus 1 over 8x plus c. But since we are given that when x equals to 9a, y equals to 9 over 4a, so we can substitute inside this equation to find what is our c. So y equals to 9 over 4a when x equals to 9a. Okay, so then my c must be equals to 9 over 4a plus 9 over 8a, and this will give me 18 plus 9, 27 over 8a. Okay, so because when 4 times 2 is 8, 9 times 2 is 18, so to combine them the same, we have to make them the same denominator in order to combine them. So 9 to 18 plus 9, 18 plus 9 is 27, so 27 over 8a. So therefore the equation of the tangent must be, if I substitute this c back into here, I get the equation of the tangent to be minus 1 over 8 x plus 27 over 8a. So this is the equation of the tangent to the curve at the point 9a, 9 over 4a. So this is tutorial 5.2, question 1 part B. You can obtain the question. I will upload the question and tell you where, and put it in the link at the bottom of this video, so that you can download and then you see what is the actual question, and then you can try to attempt first, then watch this video on how to do. Okay, thank you.